Hello sir, good evening. I am Omkar Alloli under the guidance of Professor Bharat Naik sir. I am here to present a subject seminar on ion propulsion system. So first let we know what do we mean by ion propulsion system. Ion propulsion is a technology that involves ionizing a gas to propel a craft. Instead of spacecraft being propelled with standard chemicals, the gas xenon is given an electrically charged or ionized. It is then electrically accelerated to a speed of about 30 km per second. When xenon ions are emitted with the help of ion thrusters at a high speed as exhaust from spacecraft, they push the spacecraft in the opposite direction. In some spacecraft, mm, they use chemical engines. However, ion engines work differently than chemical engines. Ion engines take very small amounts of gas and accelerate it to very high speed. Unlike chemical engines, which takes large amounts of gas and spew it out at low speed, this means that an ion engine uses a lot less fuel. So now let me know what is ion. An ion is simply an atom or molecule that is electrically charged. Now what do you mean by ionization? It is a process of converting an atom or molecule into ions. It can done by either adding or removing electrons. Then they become cation or anion respectively. So let me know what do you mean by ion thrusters. An ion thruster is a form of electric propulsion used for spacecraft propulsion that creates thrust by accelerating ions. So next, parts of ion propulsion system. Ion propulsion system consists of following five parts. First one, power source. Second one, power processing unit. Third one, propellant management system. Fourth one, the control computer, and lastly, the ion thruster. So let we know what is power source. Power source can be any source of electrical power, but solar and nuclear are the primary options. The solar electrical propulsion system uses sunlight and solar cells for power generation. So here for power generation, the solar electric propulsion system uses sunlight and solar cells. A nuclear electric propulsion system uses a nuclear heat source coupled to an electric generator. So second one is power process unit. So power process unit converts the electrical power generated by the power source into the power required for each component of the ion thruster. It generates the voltage required by the ion optics and discharge chamber and the high currents required for the hollow cathode. So third one, propellant management system. The propellant management system controls the propellant flow from the propellant tank to the thruster and hollow cathodes. So modern propellant management system units have evolved to a level of sophisticated design that no longer requires moving parts. So fourth one, the computer control. It controls the computer uh, and monitors system performance. So last one is ion thrusters. The ion thrusters that process the propellant and power to perform work. In ion thrusters, there are two types. First one is electrostatic ion thruster, and second one is electromagnetic ion thruster. So, so let me move on ion propulsion processor. So the diagram shows the ion propulsion system. Now let's discuss its processor. The fuel the fuel used in modern ion engines is xenon gases, which is 4 times heavier than air. When the ion engine is running, electrons are emitted. Here the yellow color shows the electron. Here electrons are emitted from the hollow cathode tube, which is also known as discharge cathode. This electrons enters the magnetic ringed chamber. From ring chamber it enters where they strike the xenon atoms. This electrons hits the electrons of xenon atom as it consists of 54 electrons. This results in the formation of ions in discharge chamber. Uh, as the high strength magnets are placed along the discharge chamber walls, so that as electrons approach the walls, they are redirected into the discharge chamber by the magnetic field, at the rear of the chamber. Here at the rear of the chamber, a pair of metal grids is charged positively and negatively. That is known as positive grid and negative grid, uh, with up to 1800 volts of electricity. The force of this electric charge exerts a strong electrostatic pull on the xenon ions. The xenon ions shoot out the back of the engine at high speeds, which propels the spacecraft in opposite direction and produces the thrust force. By this, it produces the thrust force. The force of this electric charge exerts strong electrostatic pull on the xenon ions. Then the xenon ions shoot out back of the engine at a high speed, which propels this in opposite direction and produces thrust. Uh, so next, amount of ion thrust. At full throttle, the ion engine will consume 2500 watts of electric power and put out 150th of pound of thrust. Ion thrusters are capable of propelling a spacecraft up to 90,000 meters per second over 2 lakhs per meter per hour. Thrusters can deliver up to zero point 0.5 newtons, that is zero point 0.1 pounds of thrust. So here are the applications of some applications of ion propulsion system. First one, ion thrusters have many applications for space propulsion. The best application of the ion thrusters make use of the long lifetime when significant thrust is not needed. This type of propulsive device can also be used for interplanetary and deep space missions where time is not crucial. Used to spiral at lower altitudes on Vesta. Help spacecraft cruise solar system on the cheap. So here are some of advantages of ion propulsion system. On propulsion could be used for a managed mission to Mars. Ion propulsion makes efficient use of the onboard fuel by accelerating it to a velocity 10 times that of chemical rockets. The ion propulsion system, although highly efficient, is very gentle in its thrust. Less expensive launch vehicle is required when compared to chemical propulsion. Less amount of propellant carrying tanks, which reduces weight of spacecraft. And last, with xenon, it is possible to reduce propellant mass on board a spacecraft by up to 90%. So some disadvantages of ion propulsion system. Here, a chemical propulsion system, ion propulsion, produces gentle amount of thrust but for a long duration. Ion propulsion system is mostly applicable only for a deep space missions. So it is only applicable for deep space missions. So it is some disadvantages. Cost of propellant used is very expensive, and it is a complex power conditioning. High it takes high voltages, and here single propellant is used. Low thrust per unit area. So lastly, conclusion. The propellant choose should not cause erosion of the thruster to any great degree to permit long life, and should not contaminate the vehicle. More efficient than the chemical propulsion. In 1998, Deep Space become the first spacecraft to use ion propulsion to reach destination in the solar system. So, thank you.